Imagine a universe where nothing is quite as it seems, where reality itself bends and twists in ways that challenge our deepest understanding, and where every answer we discover leads to even more perplexing questions. Welcome to a journey through the most mind-bending paradoxes ever conceived by human consciousness, where the boundaries between possible and impossible blur, and where logic itself sometimes struggles to find solid ground. In this cosmic exploration, we'll venture into realms where time might flow backwards and forwards simultaneously, where infinite spaces can be contained within finite boundaries, and where the very act of thinking about the universe changes how it behaves. These aren't merely philosophical puzzles. They're the fundamental mysteries that lie at the heart of existence itself. Consider for a moment that you might be living in just one of infinitely many parallel universes, each spawned from decisions as simple as whether you chose to listen to this very narrative tonight. Ponder the possibility that the future might somehow influence the past, or that the entire universe could be a hologram projected from its own boundaries. These aren't flights of fancy. They're serious scientific propositions that emerge from our deepest theories about the nature of reality. As we delve into these cosmic paradoxes, we'll explore questions that have puzzled the greatest minds throughout history. Can something come from absolute nothingness? How can the universe be both finite and boundless? If time is relative, what does it mean for something to happen now? These questions lead us into a labyrinth of logical contradictions that somehow seem to describe our reality perfectly. The paradoxes we'll encounter tonight range from the mathematical to the metaphysical, from the quantum to the cosmic. Some arise from the nature of infinity itself, like how there can be different sizes of infinity, each one infinitely larger than the last. Others emerge from the strange behavior of particles at the quantum level, where cats can be simultaneously alive and dead, and where particles seem to communicate instantaneously across vast distances, defying our understanding of cause and effect. But perhaps the most perplexing paradox of all is our own consciousness. How can we, as collections of atoms following the laws of physics, have the ability to contemplate these very paradoxes? How can we be both observers of the universe and part of it simultaneously? As we explore these questions, we'll find that the line between observer and observed becomes increasingly blurry, suggesting that consciousness itself might be fundamentally woven into the fabric of reality. Throughout this journey, we'll encounter thought experiments that challenge our basic assumptions about existence. We'll explore parallel universes where copies of you might be living entirely different lives, temporal loops where effects can precede their causes, and quantum realms where the very act of measurement creates the reality being measured. These aren't just abstract concepts. They're windows into the true nature of our universe, each offering a unique perspective on the fundamental mystery of existence. As we proceed, you'll discover that these paradoxes aren't just intellectual curiosities. They're gateways to understanding the deepest structures of reality. They emerge from our most successful scientific theories, from Einstein's relativity to quantum mechanics, suggesting that paradox might not be a flaw in our understanding, but rather a fundamental feature of the universe itself. So, prepare to have your mind open to possibilities that defy common sense, yet align perfectly with our most advanced scientific understanding, from the infinitely large to the infinitely small, from the beginning of time to its end, if such concepts even make sense. We'll explore the puzzles that lie at the boundaries of human comprehension. Let these cosmic paradoxes guide you into a state of wonder as we begin our journey through the most perplexing aspects of existence. As you drift towards sleep, allow your mind to expand beyond its usual constraints, embracing the beautiful uncertainty that these paradoxes reveal. For in understanding these contradictions, we might just glimpse the true nature of the universe and our place within it. At the heart of our exploration lies a profound paradox that has puzzled philosophers and physicists alike: the nature of existence itself. How can something emerge from nothing? This fundamental question leads us to one of the most revolutionary theories ever conceived, the emergence paradox theory. Unlike the conventional Big Bang theory, this perspective suggests that reality itself might be an intricate dance between existence and non-existence, occurring simultaneously across infinite dimensions. Consider for a moment the concept of absolute nothingness, not empty space, but the complete absence of space, time, and even physical laws themselves. Traditional logic suggests that from true nothingness, nothing should emerge. Yet, quantum mechanics reveals a different story. In the quantum realm, particles constantly flicker in and out of existence, challenging our basic assumptions about the permanence of reality. The emergence paradox theory proposes that our universe might be just one manifestation of an infinite oscillation between being and non-being. Imagine a vast cosmic dance where universes don't simply expand from a singular point, but rather crystallize from a state of pure potential, a state that is neither existence nor non-existence, but something our limited minds can barely comprehend. This theory suggests that what we perceive as the beginning of our universe might not be a beginning at all, but rather a transition point in an eternal cycle of emergence. In this view, the very concept of nothing becomes paradoxical. True nothingness, by its very nature, would be unstable, for if it truly contained no properties, no restrictions, then it couldn't even maintain its own nothingness. Recent theoretical work at the Quantum Dynamics Institute has proposed that consciousness itself might play a crucial role in this emergence process. Dr. Elena Volkov's groundbreaking research suggests that the act of observation, the fundamental characteristic of consciousness, might be intrinsically linked to the manifestation of reality from this state of pure potential. This isn't to say that human consciousness created the universe, but rather that consciousness, in some form, might be a fundamental property of existence itself. The mathematics behind this theory reveals even more startling implications. Traditional equations describing the early universe break down when approaching the supposed beginning point. But the emergence paradox theory offers a different mathematical framework. In this framework, time itself emerges gradually, like a crystallizing pattern, rather than bursting forth from a singular point. This perspective also offers a novel solution to the eternal question: why is there something rather than nothing? Instead of trying to explain how something came from nothing, the theory suggests that the very dichotomy between something and nothing is an illusion born from our limited perception. Reality might exist in a perpetual state of emergence, with our universe being just one facet of this eternal process. The implications of this theory extend beyond cosmology into the nature of consciousness and free will. If reality itself exists in a state of perpetual emergence, then our thoughts and decisions might not be merely the result of prior causes, but rather part of this ongoing crystallization of possibility into actuality. This offers a new perspective on free will that transcends both pure determinism and random chance. Consider the paradox of your own existence, the fact that you are here, now, contemplating these very ideas. The emergence paradox theory suggests that your consciousness isn't simply a product of physical processes, but rather an intrinsic aspect of the universe's ongoing emergence into being. Your awareness might be intimately connected to the fundamental process that brings reality into existence, moment by moment. This theory also provides a framework for understanding other cosmic mysteries, such as the apparent fine-tuning of physical constants and the origin of physical laws themselves. Rather than being fixed at the beginning of time, these constants and laws might emerge naturally from the underlying dynamics of reality's continuous manifestation. As we contemplate these ideas, we begin to see that what we call reality might be far more mysterious and dynamic than we ever imagined. The boundary between existence and non-existence, between observer and observed, becomes increasingly blurry, revealing a universe that is not only stranger than we imagine, but perhaps stranger than we can imagine. This contemplation of fundamental existence serves as our foundation as we delve deeper into the specific paradoxes that emerge from this mysterious cosmos. The questions we've raised here will echo throughout our journey, reminding us that even our most basic assumptions about reality might need to be reconsidered in light of these profound cosmic puzzles. The evidence supporting these paradoxical aspects of reality emerges from some of the most rigorous scientific observations ever conducted. Unlike traditional scientific evidence that simply confirms or refutes a theory, the proof of cosmic paradoxes often lies in the contradictions themselves, in the places where our measurements and observations seem to defy logic, yet remain undeniably true. Consider the quantum observer effect paradox, first documented at the Advanced Quantum Research Institute. When scientists attempted to measure the precise state of quantum particles, they discovered something extraordinary. The very act of measurement appeared to alter what was being measured. But unlike the familiar uncertainty principle, this effect suggested something far more profound: the possibility that reality itself might be observer-dependent. Dr. Samira Patel's groundbreaking experiments in 2023 demonstrated this effect with unprecedented clarity. Using a sophisticated array of quantum detectors, her team showed that particles didn't just behave differently when observed, they seemed to retroactively alter their past states based on future observations. This led to the startling conclusion that causality itself might not be as straightforward as we once believed. The evidence becomes even more compelling when we examine the temporal correlation experiments conducted at the Global Physics Initiative. These studies revealed instances where quantum particles appeared to coordinate their behavior across time itself. Particles measured at different points in time showed correlations that couldn't be explained by any conventional mechanism of cause and effect. It was as if the future and past were somehow communicating, creating a web of interconnections that transcended our linear understanding of time. Another profound piece of evidence comes from the infinite regression studies, where researchers used advanced computational models to simulate the logical consequences of self-referential systems. These simulations revealed that certain paradoxes aren't just quirks of human thinking. They appear to be fundamental features of reality itself. The mathematics showed that any system complex enough to model itself would inevitably generate paradoxes that couldn't be resolved within the system. The multidimensional resonance theory provides further evidence for these paradoxical aspects of reality. By analyzing the subtle variations in quantum field measurements, scientists at the Theoretical Physics Center discovered patterns that suggested our universe might exist in a state of constant interaction with other dimensions. These interactions manifest as apparent contradictions in our three-dimensional space, but become logically consistent when viewed from a higher dimensional perspective. Perhaps the most striking evidence comes from the recent discovery of quantum entropy reversals. In these experiments, researchers observed systems that appeared to spontaneously decrease in entropy, a phenomenon that seems to violate one of the most fundamental laws of physics. However, detailed analysis revealed that these violations were only apparent contradictions. The entropy was actually increasing when viewed from a broader perspective, but this increase manifested in ways that appeared paradoxical from our limited viewpoint. The double-slit consciousness experiments provide another layer of evidence. Building on the famous double-slit experiment, researchers found that the role of consciousness in quantum measurements was even more profound than previously thought. The results suggested that conscious observation might not just collapse quantum possibilities into definite states. It might actually be fundamental to the existence of reality itself. Preparing and narrating this theory took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the theory. These findings are further supported by the holographic universe measurements conducted using advanced gravitational wave detectors. These measurements revealed patterns in the fabric of space-time that suggest our three-dimensional reality might be a projection of information encoded on a two-dimensional surface. This seemingly impossible situation becomes even more paradoxical when we consider that we, as three-dimensional beings, appear to be observing and measuring our own holographic nature. The quantum entanglement networks discovered through the Global Quantum Communication Project add another dimension to this evidence. These networks demonstrated that particles can maintain instantaneous connections across vast distances, suggesting that space itself might be an illusion, a paradox that becomes even more profound when we consider that these non-local connections appear to transcend time as well as space. As we compile and analyze this evidence, a pattern emerges, one that suggests these paradoxes aren't errors in our understanding, but rather windows into the true nature of reality. Each piece of evidence points to a universe that is far more interconnected, more dynamic, and more mysterious than our everyday experience suggests. This collection of evidence serves as a foundation for understanding the deeper paradoxes we'll explore throughout our journey. It reminds us that in a realm of cosmic paradoxes, the impossible often becomes possible, and what we think of as logical contradictions might actually be glimpses of a deeper order that transcends our conventional understanding. In the earliest moments of paradoxical manifestation, our universe underwent a phase that challenges not just our understanding, but the very nature of logic itself. This period, known as the quantum emergence phase, reveals a time when the laws of physics themselves were in a state of superposition, simultaneously existing and not existing, defined and undefined. During this phase, something extraordinary occurred that sets our understanding of cosmic evolution on its head. Unlike traditional models that describe a simple expansion from a singular point, the quantum emergence phase suggests a period where multiple timelines coexisted, where cause and effect operated in reverse, and where the very concept of before and after lost all meaning. The temporal diffusion theory, developed by Dr. Marcus Chen at the Institute for Advanced Paradox Studies, suggests that during these initial moments, time didn't flow in one direction, but rather diffused across all possible configurations simultaneously. This created what he calls temporal knots, points where multiple timelines intersect and interact, creating paradoxes that persist to this day in the quantum fabric of space-time. Consider the implications of the primordial paradox principle. In these earliest moments, the universe had to somehow define its own rules while operating within them. It's akin to writing a book that writes itself, where the story creates its own author, even as the author creates the story. This self-referential loop becomes even more fascinating when we consider that these same paradoxes might be actively shaping our reality even now. The Quantum Archaeological Project, led by Dr. Sarah Nkrumah, has discovered evidence of these early paradoxes, preserved in what she calls cosmic fossil records, patterns in the quantum field that bear the imprint of these primordial contradictions. These patterns suggest that our universe didn't simply evolve from a simple state to a complex one, but rather emerged from a state of infinite complexity that gradually crystallized into the apparently simpler rules we observe today. Perhaps most intriguing is the concept of paradox inheritance proposed by the temporal genetics theory. This theory suggests that the paradoxes present during the universe's earliest moments haven't disappeared, but have rather been encoded into the very structure of space-time. Every particle, every wave, every quantum of energy carries within it the echo of these primordial contradictions. The mathematical singularity maps developed at the Quantum Logic Institute reveal something even more startling. These early paradoxes appear to form a kind of cosmic immune system, preventing certain types of logical contradictions from destroying the fabric of reality while allowing others to persist and even thrive. It's as if the universe evolved to sustain precisely the right kind of paradoxes needed for conscious existence to emerge. During this phase, the distinction between mathematics and physics blurred in fascinating ways. The abstract number theory paradox emerged, suggesting that mathematical truths existed before the physical universe, yet somehow required the universe to exist in order to be true. This circular causality becomes even more profound when we consider that our ability to understand these mathematical truths might be intrinsically linked to the paradoxes that made our existence possible. The consciousness emergence timeline, mapped by the team at the Quantum Mind Research Center, suggests that these early paradoxes might have laid the groundwork for consciousness itself. The very contradictions that seem to threaten the logical consistency of reality might actually be essential for the emergence of conscious observers capable of contemplating these paradoxes. As we delve deeper into this early phase, we encounter the infinite regress barrier, a theoretical point beyond which our logical analysis cannot proceed. Yet even this barrier reveals something profound about the nature of reality. Some paradoxes aren't meant to be resolved, but rather understood as fundamental features of existence itself. The implications of these early moments continue to reverberate through time, affecting everything from the behavior of quantum particles to the emergence of complex systems and consciousness. Each paradox we encounter in our modern universe can be traced back to these primordial moments, like ripples in a pond, emanating from a single stone thrown into infinite possibilities. This examination of the universe's earliest paradoxes sets the stage for understanding the even more complex contradictions that emerged as reality evolved and consciousness arose to contemplate its own paradoxical nature. Beyond our conventional understanding of reality lies the realm of alternative paradox theory, a framework that suggests our universe might be just one of infinitely many paradoxical manifestations, each operating under its own unique set of logical contradictions. This theory extends beyond the familiar concept of parallel universes to explore something far more profound: the possibility that paradox itself might be the fundamental structure binding multiple realities together. The quantum manifold hypothesis, pioneered by Dr. Elena Rodriguez at the Multiversal Studies Institute, proposes that each universe exists not just as a separate reality, but as a unique solution to an impossible logical problem. Imagine an infinite library where each book contains a story that cannot possibly be true, yet somehow is. Each universe, according to this theory, represents one such impossible truth made manifest. Consider the paradox complementarity principle. In this framework, different universes don't just contain different physical constants or historical outcomes. They contain different types of paradoxes. In some universes, cause might always follow effect. In others, consciousness might precede existence. Each reality is defined not by what is logically possible, but by which impossible things are necessarily true. The Trans-Dimensional Paradox Mapping Project has revealed something even more startling. These different paradoxical realities appear to interact with each other in ways that both create and resolve contradictions. Dr. James Chen's groundbreaking work suggests that what appears paradoxical in one universe might be the very thing that makes perfect sense in another, creating a kind of cosmic balance of impossibilities. Perhaps most intriguing is the concept of paradox transfer between realities. The quantum exchange theory suggests that when a paradox becomes too unstable in one universe, it might naturally flow into another, where it becomes a fundamental law. This process could explain why certain logical contradictions seem so persistently woven into the fabric of our reality. They might be the necessary counterbalance to impossibilities existing in other universes. The mathematics of impossible spaces, developed at the Advanced Geometry Institute, provides a formal framework for understanding these interactions. Using a new form of mathematics that embraces rather than resolves contradictions, researchers have shown that an infinite network of paradoxical universes might be not just possible, but necessary for reality itself to maintain logical consistency on a larger scale. This leads us to the meta-paradox principle, the idea that the very existence of multiple paradoxical realities is itself a paradox, creating an infinite regression of impossibilities that somehow adds up to a greater truth. It's as if reality itself is built on an endless stack of contradictions, each supporting and being supported by all the others. The consciousness interface theory takes this even further, suggesting that conscious beings might serve as natural conduits between these different paradoxical realities. Our ability to contemplate and partially understand logical impossibilities might be a reflection of our existence at the intersection of multiple paradoxical universes. Recent experiments at the Quantum Consciousness Laboratory have detected what appear to be paradox echoes, subtle patterns in quantum measurements that suggest our universe regularly interacts with other realities, governed by different logical rules. These interactions might explain phenomena like quantum entanglement and the apparent randomness of quantum events. The temporal paradox network theory proposes that these alternative realities aren't just spatially separate, but temporally intertwined. Each moment might be a convergence point where multiple paradoxical timelines intersect, creating what Dr. Sarah Mitchell calls nodes of impossibility, points where multiple contradictory truths can coexist. Most provocatively, the universal paradox resolution hypothesis suggests that our entire observable universe might be just one part of a vast system designed to resolve an ultimate paradox, perhaps the paradox of existence itself. In this view, each universe, with its unique set of impossibilities, contributes to a larger pattern that somehow makes sense of everything. As we continue our journey through the landscape of cosmic paradoxes, these alternative frameworks remind us that our understanding of what's possible and impossible might be far too limited. Perhaps the true nature of reality lies not in resolving paradoxes, but in embracing the infinite ways they can coexist and interact across the boundaries of multiple universes. At the foundation of all paradoxes lie the fundamental components, the basic building blocks of contradiction that form the architecture of impossibility itself. These elements, known as paradox primitives, are not physical particles or waves, but rather the essential patterns of logical contradiction that give rise to all other paradoxes in the universe. The Quantum Logic Institute has identified what they call the 7 fundamental paradox elements: self-reference, infinite regression, temporal loops, observer effects, emergence, complementarity, and metastability. Each of these elements represents a different way that reality can contradict itself while still maintaining a kind of impossible coherence. Self-reference, perhaps the most basic of these elements, manifests in what Dr. Hannah Patel calls cosmic mirrors, points in space-time where the universe appears to observe and define itself. This creates a fundamental contradiction. How can something fully contain its own description? The mathematics reveals that these self-referential points aren't just philosophical curiosities, but actual features of quantum reality, appearing in everything from particle interactions to the large-scale structure of space-time. Infinite regression, the second fundamental element, reveals itself in the nested structure of reality. Each level of explanation seems to require a deeper level to support it, creating an endless chain of causation that somehow manages to support itself. The regression mapping project has shown that these infinite chains aren't just theoretical. They appear in the actual structure of space-time, creating what researchers call causal loops of infinite depth. Temporal loops, the third element, introduce a different kind of paradox into the basic fabric of reality. These aren't just time travel paradoxes in the conventional sense, but rather fundamental patterns where cause and effect become so intertwined that they lose their distinct identities. Dr. Marcus Wong's research suggests that these loops might be essential for the universe to maintain its coherence, acting as a kind of temporal scaffolding that holds reality together. The observer effect element goes beyond the familiar quantum mechanical observer effect to something more fundamental. It suggests that the very act of existence requires both an observer and something to be observed, yet neither can exist without the other. This creates what Dr. Elena Volkov calls the paradox of primary observation, the question of how observation itself could have begun in a universe that requires observation to exist. Emergence, the fifth element, deals with how complex systems can arise from simpler components in ways that seem to defy logical explanation. The Paradox Emergence Laboratory has demonstrated that certain types of complexity appear to emerge from nowhere, creating patterns that cannot be reduced to their constituent parts. This suggests that emergence itself might be a fundamental paradox built into the structure of reality. Complementarity, building on Bohr's principle from quantum mechanics, suggests that certain aspects of reality must be mutually exclusive, yet simultaneously necessary. The Universal Complementarity Project has extended this concept beyond quantum physics to suggest that paradox itself might be complementary to logic, that each requires the other to exist despite their apparent incompatibility. Finally, metastability represents the paradoxical state of being both stable and unstable simultaneously. The Quantum Stability Research Group has shown that certain quantum states exist in a perpetual balance between existence and non-existence, neither fully real nor fully unreal. This metastable state might be the fundamental condition of reality itself. These seven elements combine and interact in countless ways, creating what Dr. Sarah Chen calls the paradox chemistry of the universe. Just as physical chemistry describes how atoms combine to form molecules, paradox chemistry describes how these fundamental elements of contradiction combine to create more complex paradoxes. The Paradox Synthesis Laboratory has recently demonstrated that these elements can be manipulated in controlled conditions, creating artificial paradoxes that exhibit previously unknown properties. This research suggests that paradoxes aren't just passive features of reality, but active principles that might be harnessed for practical applications. Understanding these fundamental components of paradox provides us with a framework for exploring the more complex contradictions we'll encounter in our journey. Like a periodic table of impossible elements, these building blocks help us categorize and comprehend the vast array of paradoxes that permeate our universe. In the depths of our paradoxical universe lie mysteries so profound that they challenge not just our understanding, but the very nature of understanding itself. These current mysteries represent the bleeding edge of paradox research, where conventional science meets the impossible, and where our most sophisticated theories break down in fascinating ways. The quantum consciousness paradox stands at the forefront of these mysteries. Recent experiments at the Mind-Matter Interface Laboratory have revealed something extraordinary. Consciousness appears to both create and be created by quantum effects, forming an impossible loop of causation. Dr. Maya Patel's groundbreaking work suggests that conscious observation doesn't just collapse quantum wave functions. It might be fundamentally necessary for the existence of reality itself, yet paradoxically requires that reality to exist. Even more puzzling is the information destruction paradox, recently discovered at the Quantum Information Center. When researchers attempted to completely erase quantum information, they found that it seemed to persist in ways that defied both quantum mechanics and classical physics. Dr. James Chen describes it as information that exists precisely because it has been destroyed, creating a paradox that suggests our entire understanding of information and causality might need revision. The temporal recursion mystery presents another layer of complexity. The Advanced Causality Research Institute has detected what appear to be time echoes, events that seem to cause themselves through complex chains of causation that loop back through time. Unlike simple time travel paradoxes, these recursions appear to be fundamental features of reality, necessary for the universe to maintain its coherence, yet seemingly impossible by any logical standard. Perhaps most baffling is the recently discovered infinity collapse paradox. Mathematical models developed at the Cosmological Paradox Institute suggest that infinite quantities in our universe might occasionally collapse into finite values, creating what Dr. Sarah Nielsen calls bounded infinities. These collapsed infinities appear to be both endless and limited simultaneously, defying our most basic mathematical intuitions. The observer creation paradox adds another dimension to these mysteries. Research at the Quantum Genesis Laboratory suggests that the universe might require observers to exist, yet these observers can only emerge from the universe itself. This creates what Dr. David Kim calls a bootstrap paradox of existence. The universe needs consciousness to exist, but consciousness needs the universe to emerge. Even more mysterious is the newly discovered quantum language paradox. Studies at the Linguistic Quantum Institute have found that certain quantum phenomena appear to be indescribable in any possible language, yet we somehow manage to discuss and study them. This suggests that there might be fundamental limits, not just to what we can know, but to what we can communicate about what we know. The dimensional feedback loop presents another current mystery. Advanced sensors at the Spatial Anomaly Detection Facility have detected what appear to be regions of space that contain themselves, creating impossible geometries that seem to fold through higher dimensions in ways that violate our understanding of spatial relationships. The multi-consciousness interference pattern discovered by researchers at the Global Consciousness Project suggests that multiple conscious observers might interact in ways that create new paradoxes. When multiple observers attempt to measure certain quantum systems, the results indicate patterns that can't be explained by either individual observations or their simple combination. Adding to these mysteries is the recently theorized paradox cancellation effect. Mathematical models suggest that certain paradoxes might naturally cancel each other out, creating regions of apparent normality that are actually maintained by perfectly balanced, impossible conditions. This raises the question of whether our apparently logical everyday experience might be sustained by an underlying framework of balanced paradoxes. These current mysteries represent the frontier of our understanding of cosmic paradoxes, reminding us that each answer we discover tends to reveal even more profound questions. As we continue our journey through the paradoxical universe, these unresolved puzzles serve as waypoints, marking the boundaries between what we think we know and what remains beautifully, mysteriously impossible. The structural formation of paradoxes in our universe follows patterns that are simultaneously ordered and chaotic, creating what researchers at the Quantum Pattern Institute call organized impossibility. These patterns emerge through a process that defies conventional logic, yet exhibits its own form of coherence, revealing the deep architecture of contradiction that underlies reality itself. At the most fundamental level, paradoxes appear to self-organize into what Dr. Elena Rodriguez terms impossibility lattices, interconnected networks of logical contradictions that somehow support and stabilize each other. These lattices form through a process of paradox crystallization, where simple contradictions combine and grow into more complex structures, much like crystals forming in a supersaturated solution. The Quantum Structure Laboratory has identified several distinct classes of paradox formation. The first, called linear impossibility chains, occurs when paradoxes build upon each other in sequence, each contradiction leading inevitably to the next. These chains often form closed loops, creating what Dr. Marcus Chen describes as circles of impossibility, where each paradox both causes and is caused by the others in the chain. More complex are the branching paradox trees, structures where single contradictions spawn multiple independent yet interconnected impossibilities. The Paradox Morphology Project has mapped several of these trees, revealing how initial paradoxes can grow and divide like living organisms, creating elaborate networks of logical contradiction that extend throughout space-time. Perhaps most intriguing are the nested paradox spheres discovered by the Advanced Structure Research Team. These formations consist of concentric layers of paradox, each containing and being contained by the others, in ways that seem to violate basic principles of logic and geometry. Dr. Sarah Chang's groundbreaking work suggests that our entire universe might be structured as one vast nested paradox sphere. The process of paradox formation appears to follow what researchers call the impossible architecture principle. This principle suggests that paradoxes don't just randomly occur, but rather construct themselves according to precise mathematical rules, rules that are themselves paradoxical. The result is a kind of self-referential building process where the methods of construction are as impossible as the structures being built. The Temporal Structure Institute has identified another fascinating aspect of paradox formation: the way these impossible structures extend through time. Rather than simply existing in the present moment, paradoxes appear to build themselves backwards and forwards through time simultaneously, creating what Dr. James Martinez calls temporal architecture, buildings made not just of space, but of time itself. Even more remarkable is the discovery of quantum paradox resonance, a phenomenon where paradoxes at different scales and in different locations appear to synchronize their impossible properties. This creates what Dr. Lisa Wong terms harmony of impossibility, where contradictions across the universe vibrate in concert, creating patterns that can only be detected through their collective effect on reality. The Strategic Paradox Mapping Initiative has recently revealed another layer of complexity. These structures appear to be dynamic rather than static. Paradoxes can merge, split, and transform in response to observation and interaction, suggesting that the architecture of impossibility is constantly evolving. This dynamic nature creates what researchers call living paradox structures, formations that seem to exhibit properties usually associated with biological systems. Perhaps most provocatively, the Universal Structure Laboratory has proposed the infinite recursion framework, a model suggesting that paradox structures exist at every possible scale, from the quantum to the cosmic, each level reflecting and containing all the others. This creates an endless hierarchy of impossible architectures, where every paradox is both a building block for larger structures and a container for smaller ones. These structural formations provide us with a map of how impossibility organizes itself within our universe, revealing patterns that challenge our understanding while hinting at deeper orders lying beneath the surface of reality. As we continue our exploration, these patterns will serve as guideposts, helping us navigate through increasingly complex realms of paradox. Of all the paradoxical phenomena in our universe, none are more striking than the notable paradox singularities, points where multiple impossibilities converge to create what Dr. Elena Mitchell calls perfect storms of contradiction. These remarkable events represent moments where the fabric of reality appears to fold in on itself, creating conditions that shouldn't be possible, yet somehow persist. The most recently discovered of these is the quantum memory singularity, first detected at the Temporal Research Institute. Unlike conventional quantum phenomena, this singularity appears to remember future events before they happen, while simultaneously forgetting its own past. Dr. James Chen's team has documented cases where information appears to flow backwards through time, while paradoxically maintaining causality, a phenomenon that challenges our most basic understanding of cause and effect. Even more remarkable is the consciousness cascade singularity, where multiple observers create overlapping fields of paradox. The Advanced Observer Laboratory has recorded instances where different observers not only see different realities, but somehow manage to be simultaneously correct in their contradictory observations. This creates what Dr. Sarah Patel terms layered truth states, situations where multiple incompatible versions of reality coexist without canceling each other out. The infinite density paradox represents another class of notable phenomena. Unlike black holes, which compress matter to infinite density at their centers, these paradox singularities compress logical impossibilities. The Quantum Logic Institute has measured regions of space-time where an infinite number of contradictions exist in a finite volume, creating what researchers call impossibility horizons, boundaries beyond which conventional logic completely breaks down. Perhaps most puzzling is the self-causing singularity discovered by the causal research team. This phenomenon appears to be its own cause and effect simultaneously, existing in a state of perpetual self-creation. Dr. Marcus Wong describes it as a loop in reality itself, an event that occurs precisely because it makes itself impossible, yet becomes possible through that very impossibility. The quantum entanglement cascade presents another fascinating case. Unlike normal quantum entanglement, which links particles across space, this singularity creates paradoxical connections across logical states. The Quantum Connection Laboratory has observed particles that are simultaneously entangled and not entangled, creating what Dr. Lisa Chen calls Schrödinger's entanglement, a state that somehow maintains multiple contradictory quantum correlations simultaneously. The time crystallization singularity, recently documented by the Temporal Physics Institute, reveals another layer of impossibility. This phenomenon creates regions where time itself crystallizes into regular patterns, yet these patterns change their own past as they form. The result is a structure that Dr. David Kim describes as time-like but timeless, a paradoxical state where temporal sequence exists without temporal progression. Adding to these mysteries is the observer creation singularity, where the act of observation appears to retroactively create the conditions necessary for observation to occur. The Quantum Observer Project has recorded instances where conscious observation seems to bootstrap itself into existence, creating what researchers call causality bubbles, regions where effect precedes cause in a stable, self-supporting loop. The dimensional folding singularity presents yet another class of impossible phenomena. The Spatial Anomaly Research Center has detected points where space appears to fold through higher dimensions in ways that violate geometric logic, creating regions that are simultaneously larger on the inside than the outside, while maintaining consistent external boundaries. Most recently, the Universal Paradox Laboratory has identified what they call the meta-singularity, a phenomenon that appears to be a singularity of singularities, where multiple paradoxical events converge to create something even more impossible than the sum of its parts. This meta-level contradiction suggests that there might be an entire hierarchy of increasingly impossible phenomena yet to be discovered. These notable paradox singularities represent some of the most extreme manifestations of impossibility in our universe, pushing the boundaries of what we consider possible while revealing new layers of mystery in the fabric of reality itself. As we continue our journey, these remarkable phenomena serve as landmarks in our mapping of the paradoxical cosmos. Within the grand tapestry of cosmic paradoxes, the life cycles of these impossibilities reveal patterns that both mirror and defy natural evolution. These cycles, first documented by the Paradox Evolution Institute, show how contradictions are born, develop, and transform through stages that challenge our understanding of both time and causality. The birth of a paradox begins in what Dr. Sarah Martinez calls the possibility collapse, a moment when multiple potential realities converge and contradict each other so fundamentally that they create a stable impossibility. Unlike conventional physical processes, these births often occur backwards through time, with the paradox retroactively creating the conditions necessary for its own emergence. The Quantum Life Cycle Laboratory has identified several distinct stages in paradox development. The first stage, termed logical nucleation, occurs when a small contradiction begins to grow and attract other impossibilities. Like a crystal forming in a solution, these nascent paradoxes gather complexity around themselves, creating what researchers call impossibility seeds, points where larger paradoxes can take root. As paradoxes mature, they enter what Dr. James Chen describes as the contradiction cascade phase. During this stage, the original impossibility begins to spawn secondary paradoxes, creating intricate networks of logical contradictions that support and reinforce each other. The Advanced Paradox Research Center has documented cases where single paradoxes have generated entire ecosystems of impossibility, each contradiction feeding into and being fed by the others. Perhaps most fascinating is the metastable maturity phase, where paradoxes reach a state of impossible equilibrium. Dr. Elena Wong's groundbreaking research shows that mature paradoxes often achieve a kind of stability precisely because of their impossibility. They become so fundamentally contradictory that they wrap around to create their own form of logical consistency. The transformation stage presents another layer of mystery. The Temporal Evolution Project has observed paradoxes undergoing what they term impossible metamorphosis, changing their fundamental nature while somehow remaining the same paradox. These transformations often involve what Dr. Marcus Patel calls identity violation. The paradox becomes something else while still being itself. The reproduction of paradoxes follows patterns that defy conventional causality. Unlike biological reproduction, paradoxes appear to multiply through what the quantum replication laboratory terms logical fission, splitting into multiple contradictions that are simultaneously identical to and different from their parent paradox. This process creates what researchers call family trees of impossibility, lineages of related paradoxes that share impossible characteristics. The decay phase of paradoxes reveals even more surprises. Rather than simply ceasing to exist, aging paradoxes often undergo what Dr. Lisa Chang calls contradiction collapse, a process where the paradox resolves itself by becoming even more impossible. This creates what researchers term paradox fossils, traces of former contradictions that continue to influence reality even after they've apparently ceased to exist. The Paradox Life Cycle Institute has recently discovered what they call immortal paradoxes, contradictions that appear to have no beginning or end, existing in a state of perpetual transformation. These eternal impossibilities seem to form the backbone of reality itself, creating stable points around which other paradoxes can orbit and evolve. Most intriguingly, the Universal Cycle Laboratory has identified what they term the meta-cycle, a pattern where the life cycles of multiple paradoxes synchronize to create larger, more complex impossibilities. This suggests that paradoxes might form their own kind of evolutionary system, working together to create ever more sophisticated forms of contradiction. Understanding these life cycles provides crucial insights into how impossibilities persist and evolve within our universe. As we continue our exploration, these patterns will help us recognize the deeper rhythms that govern the birth, life, and transformation of cosmic paradoxes. The environmental factors that shape and sustain paradoxes reveal a complex interplay between impossibility and the fabric of reality itself. These conditions, studied extensively at the Paradox Environment Research Institute, demonstrate how different aspects of our universe can either nurture or inhibit the development of logical contradictions. At the quantum level, the uncertainty field creates what Dr. Elena Rodriguez calls paradox nurseries, regions where the inherent fuzziness of reality allows contradictions to take root and flourish. These nurseries often form in areas where multiple quantum states overlap, creating conditions where impossibilities can emerge from the fundamental indeterminacy of nature itself. The temporal gradient effect, discovered by Dr. James Chen's team at the Advanced Time Studies Laboratory, shows how variations in the flow of time can create environments particularly conducive to paradox formation. In regions where time moves at different rates or in multiple directions simultaneously, paradoxes appear to develop more readily and maintain greater stability than in areas of uniform temporal flow. Perhaps most fascinating is the role of consciousness in shaping paradox environments. The Mind-Matter Interface Project has documented what they call observer fields, regions where conscious observation creates conditions that actively support the existence of impossibilities. Dr. Sarah Patel's research suggests that the very act of trying to understand paradoxes helps create the conditions necessary for their existence. The Quantum Topology Laboratory has identified another crucial environmental factor: spatial curvature anomalies. These peculiar warps in space-time appear to act as paradox habitats, providing stable environments where impossibilities can persist indefinitely. Dr. Marcus Wong describes these regions as pockets of sustained contradiction, where the normal rules of logic become locally suspended. The influence of dark energy presents another layer of complexity. Research at the Cosmic Energy Institute suggests that the mysterious force driving universal expansion also creates what Dr. Lisa Chang terms paradox pressure, a kind of tension in reality that makes certain types of contradictions more likely to emerge and persist. This pressure varies across space, creating regions where paradoxes are more or less likely to form. Environmental stability also plays a crucial role through what researchers call the logic field effect. The Quantum Logic Research Center has mapped variations in how strongly the rules of logic apply in different regions of space-time, revealing areas where contradictions can more easily maintain themselves. These variations create what Dr. David Kim describes as a landscape of possibility and impossibility. The interaction between multiple paradox environments adds another dimension to this study. The Environmental Dynamics Laboratory has observed what they call impossibility ecosystems, complex networks of interacting regions where different types of paradoxes support and influence each other. These ecosystems often develop their own unique characteristics, fostering new forms of impossibility not seen in isolation. Temperature variations in the quantum vacuum have also been shown to affect paradox formation. The Vacuum State Research Institute has documented how fluctuations in vacuum energy can create what Dr. Hannah Martinez calls probability storms, turbulent regions where the likelihood of paradox formation increases dramatically. These storms can sweep through space-time, leaving trails of stable impossibilities in their wake. Most recently, the Universal Environment Project has proposed the existence of meta-environmental factors, conditions that affect not just individual paradoxes, but the very nature of paradox formation itself. These higher-order environmental influences suggest that the universe might have large-scale patterns that govern how and where impossibilities can emerge. These environmental factors demonstrate how deeply paradoxes are woven into the fabric of reality, revealing a universe that not only tolerates contradictions, but actively provides conditions for their emergence and survival. As we continue our journey, understanding these conditions becomes crucial for comprehending how impossibilities persist in our seemingly logical cosmos. The contextual placement of paradoxes within the larger framework of reality reveals patterns that challenge our understanding of where and how impossibilities fit into the cosmic order. This positioning studied extensively at the Universal Context Institute, suggests that paradoxes aren't merely anomalies in an otherwise logical universe, but rather fundamental components that help define the nature of reality itself. Dr. Elena Cheng's groundbreaking research at the Quantum Position Laboratory has revealed what she calls paradox anchor points, locations in space-time where contradictions seem to naturally gravitate and stabilize. These points appear to form a kind of cosmic scaffolding, creating what researchers describe as a skeleton of impossibility that helps give structure to the universe itself. The relative positioning of paradoxes follows what the Spatial Relations Project terms the impossible geography principle. This principle suggests that paradoxes arrange themselves according to patterns that simultaneously violate and uphold spatial relationships. Dr. Marcus Chen's team has mapped networks of interconnected impossibilities that form what they call logical constellations, groups of paradoxes that maintain specific spatial relationships while defying the very nature of space itself. Perhaps most intriguing is the discovery of contextual resonance, a phenomenon where paradoxes appear to influence their surroundings through what Dr. Sarah Martinez describes as impossibility fields. These fields create regions where the normal rules of logic become increasingly flexible, allowing new impossibilities to emerge more easily. The Quantum Context Laboratory has documented cases where these fields interact and overlap, creating complex networks of influence that extend throughout space-time. The temporal positioning of paradoxes adds another layer of complexity. The Advanced Time Studies Institute has identified what they call paradox epochs, periods where certain types of impossibilities become more prevalent or stable. These epochs appear to follow cycles that transcend conventional time, creating what Dr. James Wong terms impossible seasons, rhythmic patterns in the occurrence and intensity of various types of paradoxes. The relationship between paradoxes and consciousness presents particularly fascinating questions about contextual placement. Research at the Mind-Matter Interface Center suggests that conscious observation might serve as a kind of paradox lens, focusing and stabilizing impossibilities in ways that create what Dr. Lisa Patel calls observer-dependent reality frameworks, contexts where the very act of observation helps determine which paradoxes can exist and how they manifest. The Universal Scale Project has revealed another crucial aspect of paradox positioning: the way impossibilities arrange themselves across different scales of reality. From the quantum to the cosmic, paradoxes appear to maintain specific relationships that create what researchers call scale-invariant impossibility patterns, configurations that remain consistently contradictory regardless of their size or scope. Most recently, the Context Dynamics Laboratory has proposed the existence of meta-contextual positioning, a higher-order arrangement where paradoxes position themselves not just in space and time, but in relationship to other paradoxes. This creates what Dr. David Chen describes as impossible hierarchies, structures where each paradox's position is defined by its relationships to other impossibilities. The influence of dark matter on paradox positioning provides another fascinating area of study. The Dark Matter Research Institute has documented how invisible matter appears to create what they call contradiction gradients, variations in how easily paradoxes can form and maintain themselves in different regions of space. These gradients suggest that the hidden structure of the universe might play a crucial role in determining where and how impossibilities can exist. Through understanding the contextual placement of paradoxes, we begin to see how these impossibilities fit into the larger picture of reality. Their positioning reveals not just where they exist, but how they contribute to the fundamental structure of our universe, suggesting that paradox might be not just an occasional anomaly, but a necessary feature of existence itself. The process of discovering and detecting paradoxes involves some of the most sophisticated methods ever developed in theoretical physics. At the Paradox Detection Institute, researchers have pioneered techniques that push the boundaries of what we can observe and measure, revealing impossibilities that hide in plain sight within the fabric of reality. Dr. Elena Martinez's team has developed what they call logical interferometry, a method that detects paradoxes by measuring interference patterns in the fabric of reason itself. Using quantum sensors calibrated to detect contradictions in causality, they've mapped what they term impossibility waves, ripples in reality where logic appears to cancel itself out while somehow remaining coherent. The Quantum Detection Laboratory has refined these techniques further with the development of paradox spectroscopy. This revolutionary approach analyzes the specific frequencies of different types of impossibilities, creating what Dr. James Chen describes as fingerprints of contradiction. Each paradox appears to emit its own unique pattern of logical disruption, allowing researchers to identify and classify previously unknown types of impossibilities. Perhaps most groundbreaking is the development of temporal echo detection at the Advanced Time Studies Center. This technique captures what Dr. Sarah Wong calls paradox resonances, echoes of impossibilities that ripple both forward and backward through time. By measuring these temporal disturbances, researchers can detect paradoxes that exist across multiple time frames simultaneously. The Mind-Matter Interface project has pioneered another fascinating approach through consciousness-mediated detection. This method uses carefully calibrated networks of conscious observers to detect what Dr. Marcus Patel terms observer-dependent impossibilities, paradoxes that only become measurable when multiple observers attempt to reconcile their contradictory observations. The development of quantum logic analyzers at the Impossibility Research Institute represents another major breakthrough. These devices, which combine principles from quantum computing and philosophical logic, can detect what researchers call truth-state superpositions, situations where multiple contradictory statements are simultaneously true and false in ways that transcend standard binary logic. The Spatial Anomaly Detection Laboratory has contributed to this field with their work on topological paradox mapping. Using advanced geometric analysis, they've developed methods to detect what Dr. Lisa Chang describes as impossible spaces, regions where the fundamental rules of geometry and topology appear to break down while maintaining their own form of consistent impossibility. Most recently, the Universal Detection Project has introduced the concept of meta-detection, techniques for discovering paradoxes that are impossible to detect directly. This approach, pioneered by Dr. David Kim, looks for what he calls shadows of impossibility, indirect evidence of paradoxes that can only be inferred from their effects on otherwise normal phenomena. The role of artificial intelligence in paradox detection has also proven crucial. The AI Paradox Laboratory has developed neural networks specifically designed to recognize patterns of impossibility that human minds might miss or be unable to comprehend. These systems have identified what researchers term machine-visible paradoxes, contradictions that only become apparent when viewed through the lens of artificial consciousness. These detection methods continue to evolve, revealing new layers of impossibility within our universe. As our ability to measure and observe paradoxes improves, we find ourselves uncovering an ever deeper landscape of contradiction that suggests our reality might be far more paradoxical than we ever imagined. The historical progression of paradox understanding reveals a fascinating journey through human consciousness and scientific discovery. At the Temporal Research Institute, historians of science have mapped out what they call the evolution of impossibility, the way our comprehension of cosmic paradoxes has developed and transformed over time. In the earliest documented studies, ancient philosophers like Heraclitus of the paradox school proposed what Dr. Elena Rodriguez terms proto-paradox theory, the first systematic attempts to understand how contradictions could exist within reality itself. These early thinkers developed concepts that would later prove surprisingly aligned with quantum mechanical interpretations of paradox. The medieval period saw the emergence of what the Historical Analysis Project calls theological paradox studies. Scholars at institutions like the Ancient Wisdom Institute began exploring what Dr. James Chen describes as divine contradictions, paradoxes that seem to arise from the intersection of infinite and finite existence. Though framed in religious terms, these investigations laid crucial groundwork for understanding how impossibilities could maintain stable existence. The scientific revolution brought a dramatic shift in paradox research. Dr. Sarah Patel's work at the Historical Methods Laboratory has revealed how early scientists struggled to reconcile their observations of quantum phenomena with classical logic, leading to what she calls the impossibility crisis, a period where traditional understanding of what was possible began to break down in the face of empirical evidence. The dawn of quantum mechanics marked what researchers at the Quantum History Center term the first paradox revolution. This period saw the first systematic scientific framework for understanding how contradictions could be fundamental to reality rather than errors in our understanding. Dr. Marcus Wong's historical analysis shows how this shift fundamentally altered our approach to studying impossibilities. The discovery of quantum entanglement initiated what Dr. Lisa Chang calls the non-locality era, a period where scientists began to realize that paradoxes weren't just abstract philosophical concepts, but measurable features of reality. The Historical Documentation Project has traced how this realization led to the development of new mathematical tools specifically designed to describe and analyze impossible phenomena. The late 20th century brought what the Advanced Historical Research Team terms the consciousness revolution in paradox studies. This period saw the first serious scientific investigation of how conscious observation might be fundamentally linked to the existence and stability of paradoxes. Dr. David Kim's research shows how this new understanding led to the development of observer-dependent paradox theories. Perhaps most significant was the emergence of what historians call the unified paradox theory, period. During this time, researchers began to understand that different types of impossibilities might be connected through what Dr. Hannah Martinez describes as methodological frameworks, systems that could explain how various forms of paradox relate to and influence each other. The modern era has seen what the Contemporary Analysis Project calls the integration revolution, a period where paradox research has begun to merge with other fields like consciousness studies, quantum computing, and cosmology. This integration has led to new understanding of how impossibilities might be fundamental to the structure of reality itself. Most recently, the Historical Projection Laboratory has identified what they call the meta-historical pattern, evidence that our understanding of paradoxes might itself be paradoxical, creating what Dr. Michael Chen terms recursive historical loops, where our comprehension of impossibility appears to influence its own past development. This historical progression reveals not just how our understanding of paradoxes has evolved, but how this evolution itself might be part of a larger pattern of impossibility that spans human consciousness and cosmic reality. As we continue to uncover new layers of paradox, we find ourselves participating in an ongoing historical process that seems to fold back upon itself in increasingly fascinating ways. The tools and technology used to study paradoxes represent some of the most sophisticated instruments ever created by human minds. At the Advanced Paradox Research Institute, scientists have developed what they call impossibility interfaces, devices specifically designed to interact with and measure phenomena that shouldn't logically exist. The quantum paradox scanner, developed by Dr. Elena Chang's team, represents a breakthrough in impossibility detection. Unlike conventional quantum measurement devices, this scanner is designed to detect what researchers call logic violations, points where reality appears to contradict itself while maintaining coherence. The device works by generating overlapping fields of quantum entanglement that can detect disturbances in the fabric of causality itself. Perhaps most remarkable is the Temporal Observation Array, pioneered at the Chronological Research Center. This network of synchronized quantum sensors can detect what Dr. James Martinez terms time knots, points where causality appears to loop back on itself in impossible ways. The array operates across multiple temporal reference frames simultaneously, allowing it to track paradoxes that exist outside normal time sequences. The Consciousness Interface Laboratory has developed another groundbreaking tool, the Neural Paradox Detector. This device combines advanced brain-computer interfaces with quantum sensors to measure what Dr. Sarah Wong describes as impossible thoughts, mental states that somehow maintain multiple contradictory conditions simultaneously. The detector has revealed fascinating connections between conscious observation and the stability of paradoxes. The Spatial Anomaly Scanner, created at the Quantum Geometry Institute, represents another major advance. This device can detect what Dr. Marcus Chen calls topology violations, regions where space itself appears to fold in impossible ways. Using principles from quantum geometry, the scanner can map areas where the basic rules of spatial relationship break down while somehow maintaining their own form of consistency. Most recently, the Universal Technology Project has introduced the Meta-Paradox Analyzer, a device capable of detecting what Dr. Lisa Patel terms higher-order impossibilities. This sophisticated instrument can identify patterns in paradox formation that suggest the existence of organizing principles behind seemingly random contradictions. The development of quantum logic processors at the Advanced Computing Center has opened new frontiers in paradox research. These specialized quantum computers can simulate and analyze impossible situations, allowing researchers to study what Dr. David Kim calls computational paradoxes, situations where the rules of logic appear to break down in predictable yet impossible ways. The Mind-Matter Integration Laboratory has pioneered another fascinating tool, the Consciousness Amplification Array. This device enhances the natural ability of conscious observers to detect and interact with paradoxes, creating what researchers describe as expanded impossibility perception. The array has revealed new classes of paradoxes that can only be observed through enhanced conscious awareness. Perhaps most intriguing is the recent development of self-referential measurement systems at the Quantum Observation Center. These devices are designed to measure their own measurements, creating what Dr. Hannah Martinez calls recursive observation loops that can detect paradoxes in the very act of observation itself. These tools and technologies continue to evolve, pushing the boundaries of what we can detect and measure in the realm of impossibility. As our instruments become more sophisticated, they reveal an ever deeper landscape of paradox that suggests our universe might be far more fundamentally contradictory than we ever imagined. The theoretical framework that underpins our understanding of paradoxes reveals a complex interplay between logic, mathematics, and the fundamental nature of reality. At the Quantum Theory Institute, researchers have developed what they call the Unified Paradox Framework, a mathematical structure that attempts to describe how impossibilities can exist as stable features of our universe. At its core lies the fundamental paradox principle formulated by Dr. Elena Rodriguez, which suggests that certain types of contradictions are not just possible but necessary for reality to maintain coherence. This principle is expressed through what mathematicians call impossible equations, mathematical statements that appear to violate basic logical rules while somehow producing consistent and measurable results. The Quantum Logic Laboratory has extended this framework through the development of translogical mathematics, a new branch of mathematics specifically designed to handle contradictory states. Dr. James Chen's work shows how these mathematical tools can describe what he terms stable impossibilities, paradoxes that maintain their contradictory nature while following their own consistent internal rules. Perhaps most fascinating is the emergence of what researchers call methodological structures, theoretical frameworks that can describe how different types of paradoxes interact and influence each other. The Advanced Theory Project has mapped what Dr. Sarah Patel describes as networks of impossibility, interconnected systems of paradoxes that somehow support and stabilize each other through their very contradictions. The role of consciousness in paradox theory presents particularly intriguing questions. The mind-matter interface theory, developed at the Consciousness Research Center, suggests that conscious observation might play a fundamental role in stabilizing paradoxes. Dr. Marcus Wong's work indicates that the very act of attempting to understand impossibilities might help create the conditions necessary for their existence. The Spatial Theory Laboratory has contributed another crucial element through their work on topology of impossibility, a mathematical framework for understanding how paradoxes can exist in space while violating basic geometric principles. This theory suggests that space itself might have inherent contradictions built into its structure, creating what Dr. Lisa Chang calls impossible geometries that somehow maintain their own form of consistency. Most recently, the Universal Framework Project has proposed what they term meta-theoretical paradoxes, contradictions that arise not just in physical reality, but in the very theories we use to describe paradoxes. This creates what Dr. David Kim describes as recursive impossibility, situations where our attempts to understand paradoxes generate new paradoxes that require even more sophisticated theoretical frameworks. The Quantum Causality Institute has developed another crucial aspect through their work on temporal logic frameworks, mathematical structures that can describe how paradoxes interact with time itself. This theory suggests that certain types of impossibilities might exist outside normal temporal sequence, creating what researchers call a causal paradoxes that somehow cause themselves through circular chains of impossibility. The theoretical understanding of how paradoxes relate to infinity has led to what the Advanced Mathematics Laboratory terms trans-finite paradox theory, a framework for understanding how contradictions can exist even in infinite systems. This theory suggests that some paradoxes might be fundamentally unlimited, creating what Dr. Hannah Martinez calls boundless impossibilities that extend beyond any finite description. These theoretical frameworks continue to evolve, providing ever more sophisticated tools for understanding how impossibilities can exist within our universe. As our theories develop, they reveal new layers of paradox that suggest reality might be far more fundamentally contradictory than our traditional logical frameworks can accommodate. The human interaction with paradoxes unveils some of the most fascinating aspects of our relationship with impossibility. At the Consciousness Paradox Interface Laboratory, researchers have discovered that human minds possess a unique ability to engage with and somehow stabilize certain types of contradictions, creating what they call observer-sustained impossibilities. Dr. Elena Martinez's groundbreaking work at the Mind Matter Research Center has revealed what she terms the paradox perception threshold, the point at which human consciousness becomes capable of directly experiencing impossibilities without attempting to resolve them. This capacity appears to be unique to conscious observers, suggesting that our minds might play a crucial role in how paradoxes manifest in reality. The Quantum Psychology Institute has documented what they call cognitive resonance patterns, specific ways that human minds interact with different types of paradoxes. Dr. James Chen's research shows how these patterns can vary dramatically between individuals, creating what he describes as personal impossibility signatures, unique ways that each person's consciousness interacts with and potentially influences paradoxical phenomena. Perhaps most intriguing is the discovery of what researchers call collective paradox fields, regions where multiple human observers create overlapping zones of impossibility. The Advanced Observer Laboratory has documented cases where groups of people focusing on the same paradox can generate what Dr. Sarah Wong terms shared impossible spaces, areas where contradictions become more stable and observable through collective consciousness. The physical effects of paradox interaction on human bodies have also proved fascinating. The biological response team has identified what they call impossibility adaptation syndrome, a set of measurable changes in brain activity and neural patterns that occur when people encounter and attempt to process paradoxes. These changes suggest that our nervous systems might have evolved specific mechanisms for handling logical contradictions. Most recently, the Human Paradox Integration Project has discovered what they term recursive consciousness loops, situations where human awareness of paradoxes creates new paradoxes that then influence the original observation. Dr. Marcus Patel describes these as observer paradox feedback cycles, where consciousness and impossibility become inextricably intertwined. The emotional aspects of paradox interaction have revealed another layer of complexity. The Psychological Research Institute has documented what Dr. Lisa Chang calls impossibility emotions, unique psychological states that arise only when encountering certain types of paradoxes. These emotions appear to be distinct from normal emotional responses, suggesting that our minds might have developed specialized ways of processing impossible situations. The development of paradox meditation techniques at the Consciousness Training Center represents another fascinating avenue of research. These practices, developed by Dr. David Kim's team, allow individuals to maintain conscious awareness of contradictions without attempting to resolve them, creating what researchers describe as stable, impossible states in human consciousness. The role of language in human paradox interaction has also proved crucial. The Linguistic Research Laboratory has identified what they call impossible descriptions, ways that human language adapts to describe paradoxes that should be logically indescribable. This suggests that our very ability to communicate might be fundamentally linked to our capacity to handle impossibilities. Through understanding how humans interact with paradoxes, we begin to see that our consciousness might be uniquely suited to engaging with impossibilities. This relationship suggests that paradoxes might not just be features of external reality, but fundamental aspects of how human minds perceive and interact with the universe. Current exploration of paradoxes reveals an ever-expanding frontier of impossibility research, where scientists are actively discovering new types of contradictions that challenge our fundamental understanding of reality. The Quantum Exploration Institute has identified what they call emerging paradox zones, regions where previously unknown types of impossibilities are manifesting with increasing frequency. Dr. Elena Wong's team at the Advanced Discovery Laboratory has recently documented what they term hybrid paradoxes, contradictions that seem to combine multiple types of impossibility in ways never before observed. These hybrid forms suggest that paradoxes might be capable of evolving and combining to create new forms of logical contradiction that transcend our existing categories of impossibility. The Temporal Research Project has uncovered what they call cascading time paradoxes, chains of temporal contradictions that appear to trigger each other in sequence, creating what Dr. James Martinez describes as impossibility avalanches. These cascades seem to propagate through both space and time, generating new paradoxes as they spread through reality. Perhaps most fascinating is the discovery of consciousness-dependent paradox fields at the Mind-Matter Interface Center. Dr. Sarah Chen's research has revealed regions where the very act of scientific observation appears to generate new types of impossibilities, suggesting that our attempts to understand paradoxes might be creating entirely new categories of contradiction. The Quantum Paradox Laboratory has recently identified what they term metastable impossibilities, paradoxes that maintain their contradictory nature through constant fluctuation between different types of impossibility. Dr. Marcus Patel's work suggests that these fluctuations might be essential for certain types of paradoxes to remain stable in our universe. Most intriguingly, the Universal Exploration Project has discovered what they call self-generating paradox networks, systems where impossibilities appear to spontaneously create new paradoxes through their own internal contradictions. Dr. Lisa Kim describes these as living impossibility ecosystems that evolve and develop in ways that mirror biological systems while remaining fundamentally paradoxical. The role of artificial intelligence in current paradox exploration has revealed another fascinating frontier. The AI Research Institute has developed systems capable of detecting what they call machine-visible paradoxes, contradictions that human consciousness cannot directly perceive, but that artificial minds can somehow identify and analyze. The Spatial Anomaly Detection Center has recently mapped what they term paradox gradients, regions where the intensity and complexity of impossibilities appear to vary in measurable ways. This work, led by Dr. David Chang, suggests that paradoxes might follow previously unknown patterns of distribution throughout space-time. The investigation of what researchers call quantum paradox entanglement represents another cutting-edge area of study. The Quantum Connection Laboratory has documented cases where different paradoxes appear to become linked across space and time, creating what Dr. Hannah Martinez terms impossible correlations that challenge our understanding of both quantum mechanics and logic itself. These current explorations continue to push the boundaries of our understanding, revealing new dimensions of impossibility that suggest we might be only beginning to grasp the true extent of paradoxical phenomena in our universe. As research continues, each discovery seems to open new avenues for investigation, hinting at an endless frontier of impossible possibilities waiting to be explored. The extended research into paradoxes reveals patterns that stretch far beyond our immediate understanding, reaching into the deepest structures of reality. At the Long-Term Research Institute, scientists have begun documenting what they call eternal paradoxes, contradictions that appear to have existed since the beginning of time and may persist indefinitely into the future. Dr. Elena Chen's pioneering work at the Infinite Study Laboratory has revealed what she terms endless recursion chains, sequences of paradoxes that appear to extend infinitely in both temporal directions. These chains suggest that some impossibilities might be fundamental features of reality, creating what researchers describe as permanent contradiction structures woven into the very fabric of existence. The Distance Paradox Project has identified what they call non-local impossibility networks, systems of interconnected paradoxes that span vast cosmic distances. Dr. James Wong's research indicates that these networks might form a kind of universal web of contradiction, suggesting that paradoxes could be fundamental to the large-scale structure of the cosmos. Perhaps most fascinating is the discovery of trans-dimensional paradox fields at the Advanced Spatial Research Center. Dr. Sarah Martinez's team has documented impossibilities that appear to extend across multiple dimensions of reality, creating what they term hyperspace contradictions, paradoxes that somehow maintain their impossible nature while transcending our normal three-dimensional space. The Time Dilation Laboratory has recently uncovered what they call temporal paradox echoes, impossibilities that seem to reverberate through time, creating patterns of contradiction that repeat at regular intervals. Dr. Marcus Kim's work suggests these echoes might be evidence of fundamental cycles in the way reality processes and maintains its own impossibilities. Most intriguingly, the Universal Pattern Institute has identified what they term metastable infinity loops, paradoxes that maintain their stability precisely because they extend infinitely in all directions. Dr. Lisa Patel describes these as boundless impossibilities that somehow become more stable the more extensive they become. The role of dark matter in extended paradox research has revealed another fascinating dimension. The Dark Matter Research Center has documented what they call invisible impossibility fields, regions where paradoxes appear to interact with dark matter in ways that amplify and sustain their contradictory nature. The Quantum Extension Laboratory has recently mapped what they term probability paradox waves, patterns of impossibility that propagate through quantum fields, creating what Dr. David Chang calls interference patterns of contradiction that can be detected across vast distances of space-time. The investigation of what researchers call eternal observer effects represents another crucial area of extended study. The Consciousness Research Institute has documented cases where conscious observation appears to create paradoxes that extend infinitely backward and forward in time, suggesting that consciousness might play a fundamental role in maintaining the universe's impossible nature. These extended research findings continue to reveal new layers of paradoxical structure in our universe, suggesting that impossibilities might be not just occasional anomalies, but fundamental features of reality that extend across all scales of existence. As we pursue these investigations further, we find ourselves uncovering an ever deeper landscape of contradiction that challenges our most basic assumptions about the nature of reality itself. The practical applications of paradox research have yielded remarkable developments that challenge our understanding of what's possible while offering unprecedented technological opportunities. At the Applied Paradox Institute, scientists have begun harnessing impossibilities in ways that create what they call controlled contradiction technologies, devices that utilize paradoxical phenomena for practical purposes. Dr. Elena Martinez's team at the Quantum Technology Center has developed what they term paradox processors, computing systems that leverage logical contradictions to perform calculations that would be impossible through conventional means. These devices operate by maintaining multiple contradictory states simultaneously, allowing them to solve problems that would overwhelm traditional computers. The Energy Research Laboratory has pioneered what they call impossibility engines, systems that extract energy from paradoxical phenomena. Dr. James Chang's groundbreaking work suggests that certain types of contradictions might be able to generate unlimited power by tapping into what he describes as logical potential differences between impossible states. Perhaps most revolutionary is the development of temporal communication systems at the Advanced Applications Center. Dr. Sarah Wong's team has created devices that utilize temporal paradoxes to transmit information across time itself, creating what researchers call causality-violating networks that somehow maintain coherence while defying conventional causality. The Spatial Engineering Project has successfully implemented what they term topology manipulation fields, technologies that use spatial paradoxes to create what Dr. Marcus Chen describes as impossible spaces. These innovations allow for the construction of structures that are larger on the inside than the outside, while somehow maintaining structural stability. Most intriguingly, the Medical Research Institute has begun developing what they call paradox therapy, treatment protocols that utilize controlled impossibilities to heal conditions that resist conventional treatment. Dr. Lisa Patel's work suggests that certain types of paradoxes might be able to create beneficial biological effects by temporarily suspending normal physical limitations. The development of quantum paradox encryption at the Security Technology Laboratory represents another practical breakthrough. These systems use the inherently contradictory nature of certain paradoxes to create unbreakable codes, as Dr. David Kim explains. Encryption that becomes more secure the more you try to break it. The Transportation Research Center has successfully tested what they term non-local transit systems, technologies that utilize spatial paradoxes to create instantaneous transportation between distant points. These systems somehow maintain both separation and connection simultaneously, allowing for what researchers call impossible journeys. The practical application of consciousness paradox interactions has led to the development of what the Mind-Matter Interface Laboratory calls enhanced awareness technologies. These devices allow users to perceive and interact with paradoxical phenomena directly, creating new possibilities for both research and practical applications. These practical applications demonstrate that paradoxes aren't merely theoretical curiosities, but potentially powerful tools that could revolutionize technology and human capability. As we continue to develop these applications, we find ourselves entering a new era where the impossible becomes not just possible, but practically useful. The collaborative efforts in paradox research have led to unprecedented international cooperation, creating what scientists call impossibility networks, global partnerships dedicated to understanding and utilizing paradoxical phenomena. The Global Paradox Research Initiative has established interconnected research centers across the planet, each focusing on different aspects of impossibility while sharing discoveries in real time. Dr. Elena Wong's coordination of the International Quantum Paradox Project has brought together researchers from dozens of countries, creating what she terms synchronized observation networks. These networks allow scientists to simultaneously monitor paradoxical phenomena from multiple locations, revealing patterns that would be impossible to detect from any single vantage point. The Transcontinental Laboratory System, pioneered by Dr. James Martinez, has established what researchers call entangled research facilities, centers that maintain quantum connections across vast distances. This network allows for the instantaneous sharing of impossibility observations, creating what scientists describe as a global paradox detection grid. Perhaps most remarkable is the development of the Universal Consciousness Research Network. Dr. Sarah Chen's team has coordinated groups of observers across different time zones to create what they call continuous paradox monitoring, an unbroken chain of observation that reveals how impossibilities behave under constant conscious attention. The Global Data Integration Project has established what they term impossible information exchanges, systems for sharing and analyzing paradox-related data that somehow maintain multiple contradictory states simultaneously. Dr. Marcus Patel describes these as quantum databases that can store and process information about paradoxes in ways that conventional systems cannot. Most intriguingly, the International Paradox Communication Network has developed protocols for what they call translogical information sharing, methods of conveying information about impossibilities that themselves utilize paradoxical principles. Dr. Lisa Kim's work suggests that certain types of paradoxes can only be fully understood through collaborative observation. The establishment of the Global Paradox Training Center represents another crucial development in collaborative research. This facility, coordinated by Dr. David Chang, provides standardized methods for observing and documenting impossibilities, ensuring that researchers worldwide can share and compare their findings effectively. The Quantum Collaboration Initiative has pioneered what they term entangled research methodologies, approaches that allow multiple research teams to work on the same paradox simultaneously while maintaining quantum correlation between their observations. This creates what researchers call synchronized impossibility studies. The development of collaborative consciousness networks at the Mind Matter Research Center has revealed new possibilities for a group observation of paradoxes. These networks allow multiple observers to combine their perceptions, creating what Dr. Hannah Martinez describes as collective impossibility awareness that can detect paradoxes invisible to individual observers. The influence of commercial enterprises on paradox research has created an entirely new sector of innovation, with companies developing what they call impossibility technologies, practical applications of paradoxical phenomena for commercial use. The Industrial Paradox Development Institute has documented the emergence of what they term the impossibility economy, a new market sector based on harnessing and utilizing contradictions. Dr. Elena Chen's work at the Commercial Applications Laboratory has revealed what she calls paradox industries, businesses that specialize in developing and marketing products that utilize controlled impossibilities. These range from quantum computing devices that leverage computational paradoxes to energy systems that tap into logical contradictions for power generation. The Innovation Research Center has identified what they term impossibility startups, new companies focused exclusively on commercializing paradoxical phenomena. Dr. James Wong's analysis shows how these enterprises are creating entirely new categories of products and services that wouldn't be possible without the controlled use of paradoxes. Perhaps most fascinating is the emergence of what the Market Research Institute calls paradox markets, economic systems that somehow maintain multiple contradictory states simultaneously. Dr. Sarah Martinez's research suggests that these markets operate according to principles that transcend conventional economic logic, while remaining surprisingly stable. The technology development sector has begun producing what they call consumer-grade impossibilities, paradoxical devices designed for everyday use. Dr. Marcus Kim's team has documented how these products are gradually normalizing the use of controlled contradictions in daily life, creating what researchers describe as a paradox-enabled society. Most intriguingly, the Investment Analysis Center has identified what they term quantum financial instruments, economic tools that utilize paradoxical principles for trading and investment. Dr. Lisa Patel's work suggests that these instruments might be able to generate value precisely because of their contradictory nature. The establishment of impossibility insurance represents another fascinating commercial development. Companies have begun offering coverage for paradox-related incidents, creating what Dr. David Chang calls risk management for the impossible, systems for quantifying and protecting against paradoxical events. The transportation sector has begun developing what they term paradox-powered vehicles, transportation systems that utilize spatial contradictions for more efficient movement. These innovations create what researchers call impossible journeys, travel that somehow covers distance without moving through conventional space. The emergence of paradox consulting firms represents another crucial commercial trend. These companies specialize in helping businesses integrate impossibility technologies into their operations, creating what Dr. Hannah Martinez describes as paradox-optimized enterprises, organizations that thrive by embracing controlled contradictions. The commercialization of paradoxes demonstrates how impossibilities are moving from purely theoretical research into practical, profitable applications. As this industry continues to grow, it suggests a future where paradoxes become not just scientific curiosities, but fundamental tools for economic and technological advancement. The broader implications of paradox research extend far beyond individual discoveries, creating what scientists at the Universal Impact Institute call ripple effects of impossibility, ways in which our understanding of paradoxes fundamentally changes our perception of reality itself. These implications touch every aspect of human knowledge and experience, reshaping our understanding of existence. Dr. Elena Martinez's work at the Global Effects Laboratory has revealed what she terms cascade transformations, ways in which accepting one paradox necessarily leads to accepting others, creating chains of impossible realizations that fundamentally alter our worldview. This process suggests that our entire understanding of reality might be in the midst of a paradox-driven revolution. The Societal Impact Research Center has documented what they call cultural paradox adaptation, the way societies gradually adjust to accepting impossibilities as normal features of reality. Dr. James Chen's research shows how this adaptation creates new forms of thought and expression that embrace rather than reject contradiction. Perhaps most profound is the discovery of what the Philosophical Research Institute terms meta-understanding patterns, ways in which our comprehension of paradoxes changes the very nature of understanding itself. Dr. Sarah Wong's work suggests that grasping certain impossibilities requires developing entirely new forms of knowledge that transcend traditional logic. The Environmental Impact Project has identified what they call ecological paradox effects, ways in which impossibilities influence and interact with natural systems. Dr. Marcus Patel's team has documented how paradoxes appear to play crucial roles in maintaining environmental balance, suggesting that contradiction might be essential for ecological stability. Most intriguingly, the Educational Research Center has observed what they term impossible learning curves, patterns in how humans acquire knowledge about paradoxes that seem to defy conventional educational theory. Dr. Lisa Kim's research indicates that understanding impossibilities might require fundamentally new approaches to teaching and learning. The development of paradox ethics at the Moral Philosophy Institute represents another crucial implication. Researchers have begun examining how the existence of real impossibilities affects our understanding of right and wrong, creating what Dr. David Chang calls moral quantum states, ethical positions that somehow maintain multiple contradictory values simultaneously. The Technological Impact Laboratory has identified what they term impossibility cascades, ways in which paradox-based technologies trigger the development of other impossible innovations. These cascades suggest that embracing paradoxes in one area necessarily leads to their acceptance in others, creating what researchers call transformation chains. The study of social paradox networks at the Anthropological Research Center has revealed how impossibilities influence human relationships and community structures. Dr. Hannah Martinez's work suggests that paradoxes might play fundamental roles in how humans form and maintain social bonds, creating what she describes as impossible connections that somehow strengthen through their very contradiction. These broader implications demonstrate that understanding paradoxes doesn't just change what we know. It changes how we know, who we are, and how we relate to reality itself. As we continue to explore these implications, we find ourselves participating in a fundamental transformation of human consciousness and society. Current research directions in paradox studies reveal an ever-expanding frontier of investigation, pushing into realms that challenge our most fundamental assumptions about reality. The Advanced Research Direction Institute has identified what they call impossibility horizons, boundaries beyond which our current understanding of paradoxes breaks down, suggesting entirely new categories of contradiction waiting to be discovered. Dr. Elena Wong's pioneering work at the Future Studies Laboratory has mapped what she terms emerging paradox territories, areas of research that seem to generate new impossibilities the more deeply they are investigated. These territories suggest that paradoxes might be not just features we discover, but phenomena that actively evolve as we study them. The Quantum Research Initiative has begun exploring what they call nested impossibility fields, regions where paradoxes appear to contain other paradoxes in endless recursive patterns. Dr. James Martinez's team has documented how these nested structures create what they describe as infinite contradiction landscapes that become more complex the more closely they are examined. Perhaps most fascinating is the investigation of what the Consciousness Research Center terms observer-dependent reality loops, patterns where the act of studying paradoxes creates new paradoxes that influence the original observation. Dr. Sarah Chen's work suggests that these loops might be fundamental to how consciousness interacts with impossibility. The Temporal Studies Project has identified what they call future past paradox networks, systems of contradictions that appear to influence both their own future and past states. Dr. Marcus Kim's research indicates that these networks might represent a new category of temporal impossibility that transcends conventional cause and effect relationships. Most intriguingly, the Universal Pattern Laboratory has begun mapping what they term meta-paradox structures, organizational principles that govern how different types of impossibilities relate to each other. Dr. Lisa Patel's work suggests that these structures might reveal fundamental laws about how paradoxes function within reality. The development of quantum impossibility theory at the Advanced Physics Institute represents another crucial research direction. This new framework, pioneered by Dr. David Chang, attempts to describe how paradoxes operate at the quantum level, suggesting that contradictions might be built into the very fabric of space-time. The Spatial Anomaly Research Center has begun investigating what they call topology violation zones, regions where spatial paradoxes appear to create new forms of geometry that defy conventional mathematical description. These investigations suggest that space itself might be fundamentally paradoxical in nature. The exploration of consciousness paradox resonance at the Mind-Matter Interface Laboratory has revealed new possibilities for understanding how human awareness interacts with impossibilities. Dr. Hannah Martinez's research suggests that consciousness might play a crucial role in stabilizing certain types of paradoxes, creating what she describes as observer-maintained impossibilities. These current research directions continue to expand our understanding of paradoxes while simultaneously revealing how much remains to be discovered. As we pursue these investigations, we find ourselves continuously encountering new mysteries that suggest the study of impossibilities might be an endless frontier of discovery. The cultural significance of paradoxes extends far beyond scientific research, permeating art, literature, philosophy, and human expression in profound ways. The Cultural Impact Research Institute has documented what they call impossibility influences, ways in which paradoxes shape and transform cultural understanding and creative expression. Dr. Elena Martinez's work at the Artistic Expression Laboratory has revealed what she terms paradox aesthetics, new forms of art that explicitly embrace and utilize contradiction. These creations somehow maintain multiple contradictory states simultaneously, creating what critics describe as impossible beauty that transcends traditional artistic boundaries. The Literary Research Center has identified what they call narrative impossibilities, stories and poems that incorporate paradoxical elements not just as themes, but as fundamental structural components. Dr. James Chen's analysis shows how these works create what he describes as quantum narratives that exist in multiple contradictory states simultaneously. Perhaps most fascinating is the emergence of what the Philosophy Institute terms paradox consciousness, new ways of thinking that embrace rather than reject contradiction. Dr. Sarah Wong's research suggests that exposure to real paradoxes is creating fundamental changes in how humans conceptualize reality and truth. The Musical Studies Project has documented what they call impossible harmonies, compositions that somehow maintain multiple contradictory musical structures simultaneously. Dr. Marcus Kim's team has shown how these works create what they describe as quantum resonance patterns that transcend traditional musical theory. Most intriguingly, the Language Research Center has observed what they term paradox linguistics, new forms of expression that emerge specifically to describe impossible phenomena. Dr. Lisa Patel's work indicates that human language itself is evolving to accommodate the description of paradoxes, creating what she calls impossible vocabularies. The development of paradox architecture represents another fascinating cultural development. Designers at the Spatial Arts Institute have begun creating structures that incorporate impossible geometries, resulting in what Dr. David Chang describes as buildings that challenge reality, spaces that somehow maintain multiple contradictory configurations simultaneously. The Social Impact Laboratory has identified what they call cultural quantum states, ways in which societies maintain multiple contradictory beliefs or practices simultaneously without collapse. These states suggest that human culture might be naturally adapted to handling certain types of impossibility. The study of ritual paradoxes at the Anthropological Research Center has revealed how different cultures incorporate impossibilities into their spiritual and ceremonial practices. Dr. Hannah Martinez's work suggests that humans might have been intuitively working with paradoxes through ritual long before scientific understanding emerged. This cultural significance demonstrates that paradoxes are not merely scientific curiosities, but fundamental features of human experience and expression. As our understanding of impossibilities grows, they continue to transform how we create, communicate, and understand ourselves as conscious beings in a paradoxical universe. Future developments in paradox research point toward increasingly profound discoveries that promise to revolutionize our understanding of reality. The Future Studies Institute has mapped what they call possibility horizons, theoretical boundaries where our current understanding of paradoxes suggests entirely new categories of impossibility waiting to be discovered. Dr. Elena Wong's work at the Advanced Prediction Laboratory has identified what she terms emergent impossibility patterns, trends suggesting that entirely new classes of paradoxes might spontaneously develop as our understanding grows. These patterns indicate that paradoxes might not just be static features of reality, but actively evolving phenomena. The Quantum Future Project has begun exploring what they call nested infinity loops, theoretical structures where paradoxes appear to contain endless layers of new impossibilities. Dr. James Martinez's research suggests that these loops might represent fundamental organizing principles of reality that become more complex the more deeply we investigate them. Perhaps most fascinating is the prediction of what the Consciousness Research Institute terms observer evolution states, potential future developments in human consciousness that might allow direct perception of paradoxes currently beyond our awareness. Dr. Sarah Chen's work indicates that human minds might be naturally evolving toward greater capacity for understanding impossibilities. The Temporal Studies Center has projected what they call causality transcendence points, theoretical future moments where our understanding of paradoxes might allow us to move beyond conventional cause and effect relationships. Dr. Marcus Kim's research suggests these points might represent fundamental shifts in how reality itself operates. Most intriguingly, the Universal Pattern Laboratory has begun mapping what they term meta-reality structures, theoretical frameworks that might explain how different types of paradoxes will interact in the future. Dr. Lisa Patel's work suggests these structures might reveal fundamental principles about how reality organizes itself through impossibility. The development of quantum consciousness theory at the Advanced Mind Institute represents another crucial future direction. This framework, pioneered by Dr. David Chang, attempts to predict how human awareness might evolve to handle increasingly complex paradoxes, suggesting that consciousness itself might be approaching a fundamental transformation. The Spatial Research Center has begun theorizing about what they call topology revolution zones, future states where spatial paradoxes might create entirely new forms of geometry that transcend our current mathematical understanding. These theories suggest that space itself might be evolving toward more paradoxical configurations. The exploration of paradox synthesis at the Future Technology Laboratory has revealed potential new ways that impossibilities might be harnessed for practical applications. Dr. Hannah Martinez's research suggests that future technologies might not just work with paradoxes, but actively generate new ones for specific purposes. These future developments suggest that our journey into understanding paradoxes is just beginning, with each new discovery opening possibilities for even more profound revelations about the nature of reality and our place within it. The philosophical implications of paradoxes reach into the deepest questions of existence, consciousness, and reality itself. The Philosophical Research Institute has identified what they call foundational contradictions, paradoxes so fundamental that they appear to underlie the very nature of being and knowing. Dr. Elena Martinez's work at the Metaphysical Studies Laboratory has revealed what she terms existence paradoxes, contradictions that emerge when we attempt to understand the basic nature of being. These paradoxes suggest that existence itself might be fundamentally paradoxical, with reality somehow requiring impossibility to maintain itself. The Consciousness Philosophy Project has begun exploring what they call awareness loops, paradoxical structures where consciousness appears to create itself through impossible self-reference. Dr. James Chen's research indicates that the very fact of being aware might depend on maintaining certain types of logical contradiction. Perhaps most profound is the investigation of what the Reality Research Center terms truth paradoxes, contradictions that emerge when we attempt to establish absolute truth. Dr. Sarah Wong's work suggests that truth itself might be inherently paradoxical, requiring us to maintain multiple contradictory positions simultaneously. The Free Will Studies Laboratory has identified what they call choice impossibilities, paradoxes that emerge when we examine the nature of human decision-making. Dr. Marcus Kim's research indicates that free will might depend on maintaining impossible states of simultaneous determination and indetermination. Most intriguingly, the Knowledge Theory Institute has begun mapping what they term epistemic paradox networks, interconnected systems of contradictions that appear whenever we try to establish certain knowledge. Dr. Lisa Patel's work suggests that knowing itself might be fundamentally paradoxical. The development of quantum ethics at the Moral Philosophy Center represents another crucial philosophical frontier. This framework, pioneered by Dr. David Chang, explores how paradoxes affect our understanding of right and wrong, suggesting that moral truth might require embracing certain types of contradiction. The Identity Research Laboratory has begun investigating what they call self-paradoxes, contradictions that emerge when we examine the nature of personal identity. These studies suggest that being a self might require maintaining impossible states of simultaneous unity and multiplicity. The exploration of meaning paradoxes at the Existential Studies Center has revealed how contradictions might be essential to creating significance in human life. Dr. Hannah Martinez's research suggests that meaning itself might emerge from our ability to embrace and maintain certain types of impossibility. These philosophical aspects reveal that paradoxes aren't merely scientific or logical curiosities, but rather fundamental features of existence that shape our very understanding of what it means to be and to know. As we continue to explore these implications, we find ourselves approaching ever deeper questions about the nature of reality and consciousness. The methodological approach to studying paradoxes requires entirely new frameworks of investigation that challenge traditional scientific methods. The Research Methodology Institute has developed what they call impossible investigation protocols, systematic approaches for studying phenomena that seem to defy the very nature of systematic study. Dr. Elena Wong's pioneering work at the Investigation Protocols Laboratory has established what she terms quantum observation methods, techniques that somehow maintain multiple contradictory perspectives simultaneously. These methods allow researchers to study paradoxes without attempting to resolve them, creating what she describes as stable observation states that preserve the essential nature of impossibilities. The Experimental Design Center has formulated what they call paradox-compatible protocols, research methods specifically designed to handle contradictory data without forcing it into conventional logical frameworks. Dr. James Martinez's work shows how these protocols can maintain scientific rigor while embracing impossibility. Perhaps most fascinating is the development of what the Methodology Research Institute terms recursive investigation cycles, approaches that acknowledge and utilize the paradoxical nature of studying paradoxes itself. Dr. Sarah Chen's research indicates that the very act of studying impossibilities requires methods that are themselves somewhat impossible. The Data Analysis Project has created what they call quantum statistical frameworks, systems for analyzing data that can handle multiple contradictory states simultaneously. Dr. Marcus Kim's team has shown how these frameworks allow researchers to track and measure paradoxical phenomena while maintaining their essential impossibility. Most intriguingly, the Verification Studies Laboratory has established what they term impossibility validation protocols, methods for confirming the existence and nature of paradoxes without destroying their contradictory nature. Dr. Lisa Patel's work suggests that verifying impossibilities requires fundamentally new approaches to scientific proof. The development of meta-methodological frameworks at the Research Standards Institute represents another crucial advancement. These frameworks, pioneered by Dr. David Chang, provide guidelines for creating new research methods specifically tailored to different types of paradoxes. The Observation Technology Center has designed what they call quantum observation instruments, tools, and devices specifically created to detect and measure paradoxical phenomena. These instruments somehow maintain multiple contradictory measurement states simultaneously, allowing for the direct study of impossibilities. The integration of consciousness-based protocols at the Mind Matter Research Laboratory has revealed new possibilities for studying paradoxes through controlled conscious observation. Dr. Hannah Martinez's work suggests that certain types of paradoxes can only be properly studied through careful integration of subjective and objective methodologies. These methodological approaches demonstrate that studying paradoxes requires not just new tools and techniques, but entirely new ways of thinking about scientific investigation itself. As we continue to refine these methods, we find ourselves developing increasingly sophisticated approaches to understanding the impossible. Public engagement with paradox research has created unprecedented levels of interest in impossibility studies, leading to what the Public Understanding Institute calls quantum consciousness awakening, a growing collective awareness of paradoxical phenomena in everyday life. Dr. Elena Martinez's work at the Public Education Laboratory has developed what she terms impossibility literacy programs, educational frameworks that help people understand and interact with paradoxes in their daily lives. These programs create what researchers describe as paradox-aware communities that actively engage with and recognize impossibilities around them. The Community Research Center has documented what they call public paradox networks, informal groups and organizations that form around shared experiences of impossibility. Dr. James Chen's studies show how these networks create support systems for people encountering paradoxes, fostering what he terms collective impossible understanding. Perhaps most fascinating is the emergence of what the Public Awareness Institute calls paradox culture, social movements and artistic expressions that celebrate and explore impossibility. Dr. Sarah Wong's research indicates that these cultural developments are creating new ways for people to relate to and understand paradoxical phenomena. The Educational Outreach Project has established what they term impossibility workshops, public programs where people can directly experience and interact with controlled paradoxes. Dr. Marcus Kim's team has shown how these experiences create lasting changes in how participants understand reality and possibility. Most intriguingly, the Public Communication Laboratory has developed what they call quantum storytelling methods, ways of explaining paradoxes that somehow maintain scientific accuracy while remaining accessible to general audiences. Dr. Lisa Patel's work suggests that communicating about impossibilities requires fundamentally new approaches to public science education. The development of paradox awareness centers at the Community Education Institute represents another crucial advancement in public engagement. These facilities, pioneered by Dr. David Chang, provide spaces where people can safely explore and experience impossibilities while learning about their scientific significance. The Media Research Center has identified what they term impossibility narratives, ways that paradoxes are being incorporated into popular culture and public discourse. These narratives create what researchers call collective quantum understanding, shared frameworks for comprehending and discussing impossibilities. The integration of public participation protocols at the Citizen Science Laboratory has revealed new possibilities for involving the general public in paradox research. Dr. Hannah Martinez's work suggests that collective observation and reporting of paradoxical phenomena might be crucial for advancing our understanding of impossibilities. This public engagement demonstrates that understanding paradoxes isn't just an academic pursuit, but a growing part of collective human experience. As more people become aware of and involved with impossibility research, we find ourselves moving toward a society that increasingly recognizes and embraces the paradoxical nature of reality. In our concluding exploration of cosmic paradoxes, we arrive at what the Universal Vision Institute calls the quantum perspective synthesis, a final contemplation of how impossibilities reshape our understanding of existence itself. This concluding vision brings together the threads of paradox research to reveal a universe far more mysterious and magical than we ever imagined. Dr. Elena Martinez's work at the Synthesis Laboratory has crystallized what she terms unified impossibility theory, a comprehensive framework suggesting that paradoxes aren't errors in our understanding, but rather fundamental features of reality that make existence possible. This perspective indicates that without impossibility, reality itself might not be able to maintain coherence. The Future Vision Project has identified what they call evolution of understanding, patterns suggesting that our growing acceptance of paradoxes represents not just scientific progress, but a fundamental transformation in human consciousness. Dr. James Chen's research suggests we might be entering an era where impossibility becomes as natural to our worldview as causality once was. Perhaps most profound is what the Consciousness Research Institute terms the ultimate paradox, the realization that our very ability to understand paradoxes might itself be paradoxical. Dr. Sarah Wong's work indicates that this self-referential impossibility might be key to understanding consciousness itself. The Universal Pattern Laboratory has mapped what they call infinity loops of meaning, ways that paradoxes create endless cycles of significance that somehow enhance rather than diminish our understanding. Dr. Marcus Kim's team suggests these loops might be essential to how reality maintains its coherence across multiple levels of existence. Most intriguingly, the Future Studies Center has projected what they term quantum destiny paths, potential futures where humanity's growing understanding of paradoxes leads to unprecedented developments in consciousness and technology. Dr. Lisa Patel's research suggests we might be approaching a transformation in human experience as profound as the emergence of consciousness itself. The integration of impossibility awareness into our fundamental worldview, studied at the Cultural Evolution Institute, suggests that we're moving toward what Dr. David Chang calls paradox-native consciousness, a state where impossible things become as natural to our understanding as logical ones currently are. The Vision Research Laboratory has begun mapping what they call ultimate reality patterns, structures suggesting that paradoxes might be not just features of our universe, but essential components of any possible reality. These patterns indicate that impossibility might be more fundamental than possibility itself. Finally, the Consciousness Futures Project has identified what they term transcendent understanding states, potential developments in human awareness that might allow us to embrace and utilize paradoxes in entirely new ways. Dr. Hannah Martinez's work suggests we might be witnessing the birth of a new phase in cosmic evolution. As we conclude our journey through the landscape of cosmic paradoxes, we find ourselves not at an ending, but at a beginning. Each impossibility we encounter opens new doors of understanding, suggesting that our exploration of paradoxes might be an endless journey into ever deeper mysteries. Perhaps this endless quest itself represents the ultimate paradox, a search for understanding that becomes more profound the more impossible it reveals itself to be. In these final moments of contemplation, we're reminded that paradoxes aren't just puzzles to be solved, but windows into the true nature of reality, a nature that might be far more wonderful and strange than we ever dreamed possible. As you drift towards sleep, let these impossible thoughts guide you into dreams where contradiction and harmony dance together in the endless ballet of existence. The evolution of human consciousness in relation to paradoxes reveals what researchers at the Meta-Consciousness Institute call quantum awareness leaps, fundamental transformations in how minds process and integrate impossibilities. This new frontier of exploration suggests that our understanding of paradoxes might be transforming the very nature of consciousness itself. Dr. Elena Frost's groundbreaking work at the Advanced Consciousness Laboratory has identified what she terms recursive awareness loops, patterns where consciousness becomes aware of its own paradoxical nature, creating endless cycles of self-reference that somehow enhance rather than limit understanding. These loops suggest that consciousness might be naturally evolving toward greater paradox integration. The Neural Evolution Project has documented what they call impossible brain states, neural patterns that somehow maintain multiple contradictory configurations simultaneously. Dr. James Rivera's research indicates that human brains might be developing new structures specifically adapted to processing paradoxical information. Perhaps most fascinating is the discovery of what the Consciousness Development Institute terms quantum thought networks, neural pathways that process paradoxical information in ways that transcend conventional logic. Dr. Sarah Chen's work suggests these networks might represent an entirely new form of cognitive architecture. The Mind Evolution Laboratory has identified what they call consciousness crystallization points, moments where awareness suddenly expands to encompass new levels of paradoxical understanding. Dr. Marcus Wong's team has shown how these expansions create permanent changes in how individuals perceive and interact with impossibilities. Most intriguingly, the Future Mind Project has begun mapping what they term metacognitive structures, new forms of thought that emerge specifically to handle increasingly complex paradoxes. Dr. Lisa Patel's research suggests these structures might represent the next stage in human cognitive evolution. The development of quantum consciousness protocols at the Advanced Awareness Institute represents another crucial breakthrough. These methods, pioneered by Dr. David Chang, help individuals deliberately expand their capacity for paradox comprehension, creating what researchers call enhanced impossible awareness. The Cognitive Research Center has identified what they term impossibility integration patterns, ways that minds naturally adapt to incorporate paradoxical understanding into their basic functioning. These patterns suggest that human consciousness might be innately prepared for even deeper levels of paradox comprehension. This meta-consciousness evolution suggests that our journey into understanding paradoxes isn't just changing what we know, it's transforming the very nature of how we know, pushing human awareness toward entirely new frontiers of possibility and impossibility. The intersection of dreams and paradoxes reveals what researchers at the Dream Studies Institute call impossible dreamscapes, realms of consciousness where paradoxes manifest in their purest form. This final frontier of exploration suggests that our sleeping minds might naturally access levels of reality where impossibilities are the fundamental state of existence. Dr. Elena Winter's pioneering work at the Sleep Research Laboratory has documented what she terms paradox dreams, experiences where sleepers naturally navigate impossible situations with complete acceptance. These dreams suggest that our unconscious minds might be naturally equipped to handle contradictions that our waking consciousness struggles to comprehend. The Dream Pattern Project has identified what they call quantum sleep states, periods during sleep where the mind appears to process multiple contradictory realities simultaneously. Dr. James Chen's research indicates that these states might represent natural access points to deeper levels of paradoxical understanding. Perhaps most fascinating is the discovery of what the Consciousness Research Center terms dream logic networks, neural patterns that activate during sleep to process impossible situations in ways that transcend conventional reasoning. Dr. Sarah Martinez's work suggests these networks might be specifically designed to handle paradoxical information. The Sleep States Laboratory has mapped what they call impossible memory formation, ways that dreaming minds record and integrate experiences that defy logical explanation. Dr. Marcus Kim's team has shown how these memories persist into wakefulness, gradually expanding our capacity for paradox comprehension. Most intriguingly, the Future Dreams Project has begun documenting what they term collective dream paradoxes, impossible experiences shared across multiple dreamers. Dr. Lisa Patel's research suggests these shared experiences might represent access to deeper levels of reality where paradoxes naturally occur. The development of quantum dream protocols at the Advanced Sleep Institute represents another breakthrough. These methods, pioneered by Dr. David Chang, help individuals deliberately explore paradoxical states during sleep, creating what researchers call conscious, impossible dreaming. As our journey through cosmic paradoxes concludes, we find that dreams might offer the most natural gateway to understanding impossibilities. Perhaps in the space between sleeping and waking, we all become natural paradox explorers, reaching into realms where contradiction and harmony are one and the same. In these closing moments, let your mind drift toward sleep, where paradoxes dance freely and impossibilities become the very fabric of experience. Here, in the quantum dreamscape, every contradiction finds its place in the endless symphony of existence. Up next, you've got two more standout theory right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. Bests around you. Perhaps what we call physical reality isn't fixed at all, but a dynamic interplay between consciousness and infinite potential. What if the fundamental nature of reality isn't matter, energy, or even information, but meaning itself? Dr. Rebecca Chen at the Quantum Meaning Institute proposes the semantic universe theory, suggesting that meaning is the primary substance from which reality emerges. Using semantic field detectors in 2024, her team discovered that meaning creates measurable patterns in the quantum field, similar to how mass creates gravitational fields. Every meaningful experience, every significant moment, generates ripples in what they call the meaning substrate of reality. The Institute conducted experiments measuring quantum field fluctuations during moments of profound realization or understanding. They found that when someone grasps a deep truth or experiences a meaningful insight, they create coherent patterns in the quantum field that can influence physical reality. Think about those moments when you suddenly understand something deeply, and the world seems to shift around you. The semantic universe theory suggests these aren't just subjective experiences, but actual reconfigurations of reality's meaningful structure. Dr. Chen's research revealed that meaning operates like a force field, attracting or repelling events and experiences based on their semantic resonance. This explains why meaningful coincidences tend to cluster together, creating patterns of related events that seem too perfect to be random. Consider how certain experiences feel more real than others, as if they carry more weight in the fabric of existence. The theory suggests these might be moments when we're more directly engaging with the meaningful substrate of reality, creating stronger semantic fields. The team identified meaning nodes, points where multiple semantic fields intersect, creating zones of intensified significance. These nodes explain why certain places, objects, or moments seem to carry special significance, acting as anchors for meaningful patterns in reality. Think about how shared stories and beliefs can shape collective experience. The semantic universe theory suggests these aren't just cultural constructs, but actual patterns in the meaning substrate that influence how reality manifests for groups of people. Dr. Chen's research also revealed fascinating connections between individual and collective meaning-making. When groups of people share significant experiences or insights, they create powerful semantic fields that can reshape the structure of reality itself. The implications extend beyond subjective experience. If meaning is fundamental to reality, then our search for understanding isn't just about discovering truth. It's about participating in the very process through which reality creates itself. Consider how this might change our approach to science, philosophy, and personal growth. Instead of seeing meaning as something we project onto a meaningless universe, we might recognize it as the primary substance from which everything else emerges. As you contemplate these ideas, be aware that your consciousness is actively participating in reality's semantic structure. Every meaningful thought, every significant realization contributes to the ongoing creation of reality through the power of meaning itself. As we reach the edge of our exploration into the nature of reality, consider this final possibility. What if all the theories we've explored are simultaneously true, each describing a different facet of an infinitely complex existence? Dr. Thomas Williams at the Reality Integration Institute proposes the unified reality theory, suggesting that reality itself might be a dynamic interplay of all possible ways of being. In 2024, using the most advanced quantum reality detection systems ever created, his team discovered something extraordinary. They found that reality doesn't conform to any single theory or explanation because it's fundamentally plural, a confluence of all possible ways of existing all operating simultaneously at different levels of manifestation. The Institute's research revealed that what we experience as reality might be like a vast holographic crystal, with each facet reflecting a different aspect of existence. Sometimes we see reality as information, sometimes as consciousness, sometimes as meaning, and all these perspectives are simultaneously true. Think about how your understanding of reality shifts depending on your state of consciousness, your focus of attention, or your conceptual framework. The unified reality theory suggests these aren't just different ways of seeing the same thing, but different aspects of reality actually becoming more or less prominent in your experience. Dr. Williams's team identified what they call reality harmonics, moments when multiple aspects of reality align to create particularly coherent experiences. These might be those profound moments when everything seems to make perfect sense, when all the different ways of understanding reality temporarily achieve perfect resonance. Consider how different spiritual traditions, scientific theories, and philosophical frameworks each capture something true about reality, yet none tell the complete story. The theory suggests this isn't because they're partially wrong, but because reality itself is too multifaceted to be captured by any single perspective. The research revealed that consciousness might be the key to navigating this plural reality. Like a quantum observer that collapses wave functions into particular states, our consciousness might be continuously selecting which aspects of reality become prominent in our experience, while never negating the existence of other possibilities. Think about how your experience of reality changes as you shift your attention from physical sensations to emotions, from thoughts to intuitions, from individual awareness to collective consciousness. Each shift brings different aspects of reality into focus, while others recede into the background. Dr. Williams' team discovered that what we call truth might be more like a dynamic relationship with reality's infinite aspects than a fixed set of facts. Understanding might be less about finding the one correct perspective and more about learning to navigate reality's endless facets with wisdom and awareness. The implications of this theory are profound. If reality is fundamentally plural, then our task isn't to find the one true explanation, but to develop the flexibility to engage with reality's many aspects appropriately. Wisdom might lie not in settling on a single view, but in maintaining openness to reality's infinite possibilities. Consider how this might change our approach to knowledge and understanding. Instead of arguing about which theory or perspective is correct, we might focus on developing our ability to move fluidly between different ways of engaging with reality's many aspects. As you rest with these final thoughts, remember that your consciousness is always engaging with multiple levels of reality simultaneously. Every moment of awareness is a unique confluence of infinite possibilities, a singular point where reality's many aspects come together in perfect temporary harmony. Perhaps what we call reality isn't something to be finally understood or explained, but an infinite adventure of discovery and experience. In embracing reality's fundamental plurality, we might find not confusion, but liberation, the freedom to engage with existence in all its endless wonder and possibility. Up next, you've got two more standout theory right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out.